Okay, let's take a look at some examples for solving one and two step equations. The first equation we're going to look at is this one in front of us. N minus 3.24 is equal to 42.1. Okay. The first thing to do when you're solving any equation is we want to separate the left and the right side of the equation. So I just draw a line down. If we're looking to solve for our variable n, then we want to eliminate any term that's not our variable term on that left side of the equation. Okay, so we're trying to isolate n, and we can do that by simply doing the inverse and adding 3.24 to both sides of the equation. When you do that, that eliminates this term on the left side, and you're left with just your variable 1n on the left side of the equation. On the right side, now you just add those two values together, and that should give you 45.34 as your solution. Okay, so we're using the inverse there just by adding that constant term to both sides, and it allows you to solve your equation. Let's take a look at a one-step equation that's a little bit more challenging, and this one's going to involve multiplication. So our example here is going to be negative 5/8 times x is equal to 20. And again, we want to figure out what our variable x should be equal to. Okay. So when you read that equation, it's asking you to multiply your variable x by negative 5/8. Okay. So if we want to solve for x, we want to do the inverse. We want to divide by negative 5/8. Okay. So again, I'm going to draw a line straight down to separate the left and the right. And we're going to divide both sides by negative 5/8. Okay. So if you notice that undoes your original multiplication in the beginning of the problem. Okay. And so on the left side, you're left with your variable, which is what you wanted to solve for. You've isolated that. On the right side, now it's asking you to divide 20 by a fraction, by negative 5/8. Okay. So I'm going to represent this a little bit differently. We'll have 20 over 1, and it's being divided by negative 5/8. Okay. It might be easier to solve this one instead of dividing 20 over 1 by negative 5/8. Okay. We can do something called multiplying by the reciprocal. Okay. So we can simply take our 20 over 1, and this time we'll multiply it by that negative 5/8. The reciprocal of that would give you a negative 8/5. Okay, so you can just switch your numerator and your denominator, and if you flip those, you have a multiplication problem that you can finish. Okay, so now we've got two fractions that we want to multiply together. In our numerator, 20 times a negative 8, that ends up being negative 160. Okay. And then in our denominator, if we multiply our fractions straight across, 1 times 5 ends up with a denominator of 5. Okay. If you simplify negative 160 divided by 5, okay, that allows you to solve your problem there. 5 will go into 160 32 times. Okay, so your solution there will be x is equal to a negative 32. Okay, and we did that essentially by multiplying by the reciprocal. All right, so those are some examples of solving one-step equations. Let's take a look at a two-step equation. All right, so the example that we'll do is this one here. 5 plus 4x is equal to 33. Again, the intention of solving this equation is to solve for x. So you want to isolate your variable on one side. And to do that, we've got to use our golden rule of algebra. So that means that to eliminate a term on any side of the equation, that you want to use the inverse. Okay, the inverse of whatever operation is being implied. Okay, so we've got 5 plus 4 times x is equal to 33. That 5 is a positive 5, so we can eliminate our constant here by subtracting 5 from both sides. When you do that, we're left with 4x on the left side of the equation. On the right side, 33 minus 5 gives you 28. Okay, and now we have a whole new equation rewritten, and it's 4 times x is equal to 28. Again, if we want to solve for x, we want to isolate x. Okay, we can use our golden rule of algebra, and instead of multiplying by 4, we can divide by that same coefficient of 4. Okay, and that will tell us what our variable x should be. Okay, when we divide both sides by 4 on the left side, you're left with x. On the right side, 28 divided by 4 gives you a value of 7. Okay, so that's your solution for that particular example. X should be equal to 7. All right, finally, I'm going to show you one other two-step equation, and that's going to involve that term. Okay, this is your equation for that example. -6 is equal to our variable n divided by 2 minus 10. Again, we'll draw down our line from the equal sign to separate our left and right side of the equation. And we want to think about how to best solve for your variable n. And to do that, to isolate n, we can simply eliminate that constant on the right side. Okay, so to eliminate it, we can use the inverse, and instead of to eliminate the -10, we can add 10. Okay, we can add 10 to both sides of the equation. Okay, when you add 10, that eliminates that constant on the right side. On the left side, -6 plus 10 ends up giving you a +4. Okay, and now on the right side of the equation, n divided by 2 is equal to +4. Now this rewritten equation suggests that you're dividing your variable term by 2, and that would give you 4. Okay, to eliminate that division by 2, we could simply multiply both sides by 2. Okay, you can multiply by 2 on both sides, and that essentially undoes your division. Okay, because it's the inverse of dividing by 2. All right. On the right side, if you've undone your division, you're left with your variable n. On the left side, 2 over 1 times 4 over 1, 2 times 4 would give you 8. Okay, so your solution there would be that your variable n should be equal to 8. One last thing, we can always check our solution to our equation by substituting it back in. Okay, our original equation was -6 is equal to your variable n divided by 2. Okay, in this case, our solution for n was 8. So we can divide that by 2, subtract 10 from it, and see if we get -6. Okay. All right, so 8 divided by 2, that gives you 4. If you subtract 10 from 4, you do in fact get -6. Okay, so this is a true statement, and that means that our our solution is the correct one, and is going to be equal to 8.